Hi, I'm Kuba, and this time we'll use a feature store with graph embeddings. Check it out! Graphs are structures which contain sets of entity nodes and edges, which represent the interaction between them. Such data structures can be used in many areas like social networks, web data, or even molecular biology for modeling real-life interactions. To use properties contained in the graphs in the machine learning algorithms, we need to map them to more accessible representations called embeddings. In contrast to the graphs, the embeddings are structures representing the node's features and can be easily used as an input of the machine learning algorithms. Because graphs are frequently represented by the large datasets, embeddings calculation can be challenging. To solve this problem, I will use a very efficient open-source project, Cleora, which is entirely written in Rust. Let's follow the Cleora algorithm. In the first step, we need to define the number of features which will determine the embedding dimensionality. Then we initialize the embedding matrix. In the next step, based on the input data, we calculate the random walk transition matrix. The matrix describes the relations between nodes and is defined as a ratio of number of edges running from first to second node and the degree of the first node. The training phase is iterative multiplication of the embedding matrix and the transition matrix, followed by L2 normalization of the embeddings rows. Finally, we get an embedding matrix for the defined number of iterations. Moreover, to be able to simply build a solution, I have extended the project with possibility of reading and writing to S3 store and Apache Parquet format usage, which significantly reduce embedding size. Additionally, I have wrapped the Rust code with the Python bindings, thus we can simply install it and use it as a Python package. Based on the Cleora example, I will use the Facebook dataset from Snap to calculate embeddings from page-to-page graph and train a machine learning model which classifies page category. In the first step, we need to prepare the input file in the appropriate click or star expansion format. Then we use Cleora Python bindings to calculate embeddings and write them as a Parquet file in the S3 Minio store. For each node, I have added an additional column which represents timestamp and will help to check how calculated embeddings will change over time. Now we are ready to consume the calculated embeddings with Feast feature store and Yummy extension. Finally, we train page classifiers. Because feature store can merge multiple sources, we can easily enrich graph embeddings with additional features like additional page information. We can also track embeddings' historical changes. Moreover, using feature store, we can materialize embeddings to online store, which simplifies building a comprehensive mlops process. You can find the whole code on GitHub and detailed description on my blog and Yummy documentation. Thus it should be relatively simple to reproduce all steps with Docker. That's all for today. Please subscribe And thanks for watching. Bye!